Imagine finding a heavy metal coin deeply buried in the forest dirt. You wipe away the dust, and the stamped date is older than the Earth itself. This is exactly what puzzled astronomers found hiding in the deep dark of space. They discovered a faintly burning star that seemed absolutely impossible to exist.
We call it the Methuselah star. It sits roughly 190 light-years away from our planet, quietly glowing in the peaceful night sky.
For decades, scientists knew this lonely cosmic object was extremely old, but they were entirely unprepared for what the numbers would finally reveal to them. According to early calculations, this faint star was 16 billion years old. That created a massive, terrifying problem for every single physicist on Earth. Our universe is widely accepted to be exactly 13.8 billion years old. The Big Bang sparked the dawn of time exactly that long ago. So how could a star be over 2 billion years older than the universe? It is just like a child being older than their own mother. The global astronomy community quietly panicked over this bizarre discovery. If this single star was truly 16 billion years old, our understanding of reality was broken. Did we completely miscalculate the rapid expansion of the early universe? Or was there a strange hidden flaw in how we measure the age of stars? To solve the mystery of this impossible cosmic ghost, we have to look closely at the star itself, and it is a very weird star indeed. Most stars in our galaxy quietly sit inside a flat, spinning disk, but the Methuselah star does not belong to this normal, comfortable neighborhood. It is plunging straight through the flat disk of the Milky Way. It moves at an astonishing speed of 1.3 million kilometers per hour. If you could look up and watch it over a human lifetime, it would actually shift its position. Very few distant stars move that noticeably. Scientists quickly realized this star is an ancient, wandering trespasser. It was definitely not born here in the comfortable spiral arms of our home galaxy. Billions of years ago, the Milky Way collided with a tiny dwarf galaxy. Our massive galaxy shredded the smaller one into absolute pieces of space dust. The Methuselah star is a lonely survivor from that ancient, violent collision. It was violently thrown into a strange looping orbit around our galactic center. It has been traveling on this isolated high-speed path ever since, but its extreme speed was only the first hidden clue to its incredible age. To truly understand how old a star is, scientists have to deeply read its light. They split the starlight into a rainbow to uncover its secrets. This colorful rainbow shows dark lines that act exactly like a chemical barcode. It tells us exactly what the deep inside of the star is made of. When the universe was born, there was absolutely no iron, carbon, or oxygen. There was only simple hydrogen, some helium, and a tiny bit of lithium. All the heavy metals we know today were slowly forged inside the bellies of dying stars. When those early stars exploded, they scattered metals into deep space. The next generation of stars scooped up those loose metals when they finally formed. Our sun is a very young star, densely packed with heavy elements. When scientists looked closely at the chemical barcode of the Methuselah star, they were stunned. It was almost completely empty of any heavy space metals. It actually contains 250 times less iron than our own sun. This means it formed long before the universe had time to make metals. It is a beautiful relic from a time when the cosmos was pristine and dark. But then, a very strange problem suddenly appeared in the astronomical data. Even though it was clearly an ancient, metal-poor star, it was still shining quite brightly. Usually, massive, bright stars quickly burn out and die away entirely. Small stars live much longer, but they are very dim and glow a deep red. The Methuselah star is somewhere in the middle, expanding into a bright subgiant. It is currently running completely out of hydrogen fuel in its core. To stay alive, it is starting to furiously burn hydrogen in a shell around its center.
This dramatic process causes the star to puff up and become increasingly brighter. By measuring exactly how bright it is, we can calculate how long it has been burning.
In the year 2000, a dedicated team used a satellite to measure this brightness. They fed the complex numbers into their supercomputers to get a precise age.
The humming computer spat out the impossible number of 16 billion years. The scientists checked the math again and again, but the bizarre result stayed exactly the same.
Shocking news spread around the world that an impossible star had been found. It deeply threatened to shatter the Big Bang Theory into a million tiny pieces.
If the universe was only 13.8 billion years old, modern physics was broken. Some worried people wondered if there was a completely different universe before our own.
Could this star have somehow crossed over from a previous universe that utterly collapsed? It sounded like pure science fiction, but the stubborn numbers were right there.
To desperately save modern physics, astronomers needed to find a flaw in the original measurement. They realized the old satellite data might have been slightly blurry. If they did not know exactly how incredibly far away the star was, they could not know its true brightness. Distance in deep space is notoriously tricky. If a light looks faintly dim, it might just be a small flashlight up close, or it could be a massive blazing lighthouse located extremely far away. To measure the exact true distance to the Methuselah star, we needed the best eye in the sky. Enter the legendary, powerful Hubble Space Telescope.
Hubble peacefully floats above our blurry atmosphere, seeing the universe in crystal clear detail. Scientists carefully pointed its cameras at the star for several long years.
They used a brilliant, clever trick called stellar parallax to finally find the distance. It is actually something you can easily test with your own two eyes. Hold your thumb out and close your left eye, then quickly switch and close your right eye. Your thumb appears to magically jump back and forth. This happens because your eyes are a few inches apart, giving you two different viewing angles. Earth does the exact same thing as it orbits the glowing sun. In the warm summer, Earth is on one side of the vast solar system. In the cold winter, it is hundreds of millions of kilometers away on the other side. By taking detailed pictures 6 months apart, Hubble looked at the star from two different angles. It perfectly measured how much the distant star seemed to visually shift. Because the star is so incredibly far away, the visual shift was totally microscopic, but Hubble is sensitive enough to measure the width of a human hair from miles away. After years of careful, patient photography, the team finally had a highly precise distance. It was exactly 190.1 light-years from Earth. With the exact distance finally known, they could calculate the exact cosmic brightness. They suddenly discovered the star was slightly brighter than they originally thought. If the star was burning brighter, it meant it was using up its fuel much faster. A faster burn rate means the star is actually slightly younger. The excited team gathered the new data and ran the supercomputer models once again. The entire physics community waited with bated breath for the final results. The machine gave a slightly newer age of 14.4 billion years. The number had wonderfully dropped, but a massive problem still stubbornly remained. 14.4 billion is still much greater than 13.8 billion. The Methuselah star was still impossibly older than the entire known universe. But then something very subtle happened in the endless scientific calculations. The astronomers looked closely at the chemical makeup of the star once more. They realized that while the star completely lacked iron, it had a surprisingly high amount of oxygen. Oxygen drastically changes how a star burns its core. Deep inside the star, oxygen acts like a special catalyst for intense nuclear fusion. It fundamentally changes the way heat violently flows outward from the center. The scientists adjusted their math to properly account for this heavy oxygen content.
The new calculations shaved off a few more million years from the massive age.
The final age estimate firmly settled at exactly 14.2 billion years. It was much closer, but it still defied the known laws of space and time. Was the Big Bang Theory finally dead after all these decades? Some rogue scientists eagerly wrote papers claiming our universe was simply older than we originally thought. But the lead astronomers knew one crucial detail that the flashy news headlines ignored. It is called the margin of error, and it changes absolutely everything. When you confidently calculate something this complex, you can never be absolutely perfect. There is always a tiny, frustrating range of mathematical uncertainty in the final number. For the Methuselah star, the calculated margin of error is roughly 800 million years. This means the star could be that much older or that much younger. If you take the estimate of 14.2 billion and subtract 800 million, magic happens. You perfectly land at 13.4 billion years. The proven age of the universe is 13.8 billion years. The absolute youngest the star could be fits perfectly inside that tight cosmic window. The great cosmic paradox was finally and completely solved. Physics was not terribly broken, and the Big Bang Theory was completely safe from utter ruin.
However, even at 13.4 billion years old, this star is a true miracle. It was born a mere 400 million years after time itself began.
During that ancient era, the universe was a violent, dark place filled with swirling gas. The very first infant galaxies were only just beginning to take fragile shape.
The Methuselah star ignited in this thick primordial darkness and has survived ever since. It has silently watched entire galaxies violently collide, die, and be totally reborn. While our own sun is only 4.6 billion years old, Methuselah is ancient. It has been shining 3 times as long as our solar system has existed.
Think of all the deep history that has passed while this star silently burned. It watched from afar as the rocky Earth slowly formed from floating dust.
It was warmly shining when the empty oceans filled with water and the first single-cell life appeared. It cast its faint light when giant dinosaurs walked the planet.
Through every single era of Earth, this ancient wanderer has been hurtling through our galaxy, and its long, incredible galactic journey is far from being over. Today, it is in a beautiful transitional phase of its very long life. It is slowly swelling into a giant red balloon as its deep core heats up. Eventually, it will quietly burn away the last scraps of its internal hydrogen fuel. Without the outward energy of nuclear fusion, relentless gravity will quickly take control. The outer dusty layers of the star will gently drift away into the cold void of space. They will form a beautiful, glowing cloud of rich, colorful gas. What remains in the dead center will be a tiny, intensely glowing white dwarf. It will be a terribly hot cinder, no larger than the Earth itself. This tiny glowing remnant will slowly cool down over trillions of quiet years. Long after our bright sun is gone, the cold ghost of Methuselah will still be there. It reminds us that the universe is vast, intensely patient, and full of hidden records. The answers to our deepest questions are out there, silently waiting to be found. But finding those hidden answers requires us to be completely humble. The cosmos loves to throw us a wild curveball that makes us question everything we know. When the data told us a star was impossibly older than time, we did not give up. We built better telescopes, refined our complex math, and looked much deeper. Step by step, science peeled back the thick layers of a 16-billion-year-old mystery. We found the beautiful truth hiding in the microscopic mathematical details. The Methuselah star is no longer a paradox that carelessly breaks the laws of physics. Instead,
It is a glorious, glowing bridge to the very dawn of time.
It is a stunning survivor from the absolute first generation of cosmic fire, a quiet, steady lighthouse from an ancient era we can barely even imagine.
The next time you step outside into the cool night air, look up toward the constellation Libra. You will unfortunately need a decent telescope to actually see it. But just knowing it is up there brings a wonderfully strange sense of peace. A billion-year-old lonely traveler, quietly keeping the secrets of the ancient dark.
As you softly lay your head down to sleep, think about that immense cosmic journey, from a cloud of primordial gas to a speeding beacon in our night sky. The universe is softly singing a very long, very beautiful, and slow song. The Methuselah star is one of the oldest and most beautiful notes in that grand melody.
We are incredibly lucky to exist at a time when we can clearly see it. We get to read its ancient light and finally understand where we truly came from. There are surely other ancient mysteries out there, hiding in the starry black ocean. They are patiently waiting for a curious human eye to spot them in the dark. Until then, we can peacefully drift off to sleep, knowing the cosmos is full of wonders, and some ancient stars simply refuse to ever fade away.
Thank you for peacefully traveling through the ancient universe with us tonight. May your deep dreams be as vast and peaceful as the endless night sky above.
If you enjoyed this cosmic bedtime story, please leave a gentle like and subscribe to the channel. There are so many more wonderful space mysteries waiting for you to discover.